And I think we discovered that it was very, very easy to use, right? All right, so here's the deal. I want to do a little bit of this, and then at the end of the period, I know there were a couple tricky homework questions, so if you want, we can do a couple of homework questions together. So if your paper's in the plate, you can get it out later, I know. Okay, so let's look at question number 2 on page 41. The question is different, okay? I mean, obviously, the question doesn't say solve the triangle. It says how many triangles are possible. So I'm just going to draw my random triangle here, and I'm going to label it. Okay, A is 20 degrees. Side A is 12. Remember how we do that? And might be easier for me to put B. Let me put B there. That might be easier for you. And side B is 31. It doesn't make a bit of difference. I'm just trying to keep everything set up as easy as I can for you. Okay? Now, would you agree that I have a matched set right here? And whenever I have a matched set, A and A, B and B, C and C, I can do the law of sines. So I'm going to do that. So sine 20 over 12 will equal what? Sine B over 31. So yesterday I had all my angles and I was looking for sides. Now I'm looking for an angle. So let's go ahead and cross multiply just like we do. 12 sine B equals 31 sine 20. Cross multiply. Now this is your variable, okay guys? So what are you going to divide by? You're going to divide by just 12. So sine B equals 31 sine 20 over 12. Now I see the calculator's out, and that's okay. But if you're typing this in, you need to understand that isn't your answer. That is not angle B. That's going to be some decimal, probably what it is, but it's going to be some decimal. That is the sine of angle B. What did we learn back in chapter 4? If we are trying to find an angle, if an angle is our variable, what do I have to type in on my calculator? Inverse sine, inverse sine. So you're not typing this in. You're typing in you're typing in inverse sine that number. Okay, do you get that? You see how it connects to before? When you were trying to find an angle, didn't you have to do second tangent or second cosine or something? That's exactly what we have to do. Second sine. So, let's type it in. So second sine, the parentheses come up automatically. 31 sine 20. Now close it around the 20. You always have to close around your angle. And then divide it by 12. Did you get 62.07? So angle B is 62.07. Right, now here's where, I'm going to explain to you why we have an issue in a minute, but here's the next step in the problem. Every time you do this, you're going to have 2 steps to your problem, okay? You did the first step already, you got 61.07. Now, I want you to redraw the triangle, label everything exactly the same. Only leave that B blank, all right? how many triangles are possible? It's possible there's another angle B. So the first one, we typed it in our calculator and we got it. If there is another angle, it will be 180 minus the first one. Now there's math behind that. I'm not going to try to explain it. It's not bad, it's pretty easy to explain, but just know, if there is another angle, it's 180 minus the first one, okay? So what would that be? 180 minus the first one is 117.93. Now you're not solving this triangle. You are just trying to figure out, am I going to have one angle B or can I have another angle B? And the answer is, I can have both of those. Both of those are okay. So how many triangles are possible? 2. Now let me show you what would happen if there weren't 2. Okay, so first of all, the answer to the question is always going to be 0, 1, or 2. The minute I got an answer on my calculator, I know there's going to be at least 1. 62 was one of my B's. I subtracted it from 180 and got this, and that's a good answer. Also, I'm going to show you why, and therefore both are possible. There's 2 possible triangles. Okay? Now, I'm going to show you something. Let's suppose the original angle, instead of being 20, let's suppose it had been 70. That would not be a possible answer. Because why? What is wrong if that first angle had been 70? It wasn't. But what if it was? What if it were 20 or 70? Why would this not be acceptable? It'd be over 180. So sometimes when you find that second angle, it makes more than 180 in your triangle. And therefore, in this case, that one wouldn't work and there would be only one possibility. We're going to run into one that has no answers here, and we'll see what happens then. Okay?
Do people take the answer that you got from the 180 minus 6287 and then do that again to find more triangles?
No. There's 0, 1, or 2. 0, 1, or 2. That's your answer. So let's go through another one. Make sure you see how this works. So here's angle A at 76. Side A is 18. B, I don't know what B is, but side B is 20. Remember, you aren't solving. This isn't like we did yesterday, where we had to find all the missing things. We are simply wanting to figure out, do I have a triangle? Do I have one triangle? Do I have 2? After I do this, I'm gonna show you why this is an issue, why this happens. But let's just start cranking it out. Sine 76 over 18. Would everybody agree step 1? Equals what? Sine B over 20. Cross multiply 18 sine B equals 20 sine 76. And then what are we dividing by this time? Just 18. This is your variable. So we're going to divide by 18. And it says sine B equals 20 sine 76 over 18. I don't want sine B. You can go ahead and type that in, but it's going to be a meaningless decimal. You need to know angle B. So how do we get angle B? What do we type? B equals inverse sine that thing. All right, so here we go. second sine 20 sine 76, close the parentheses, divided by 18. You got an error, I got an error, everybody got an error. How many triangles possible? Zero. When your calculator says can't do it, that means that information does not make a triangle. You cannot have those angles and sides and make a triangle. So the answer to question number 2 is, or B, 0. Remember, your answer is 0, 1, or 2. We've done a 2, now we've done a 0. Now, before we go on, we're going to do the rest of them. Before we do, I want to show you, hopefully, why this is happening. Let's look at the original picture that I drew. Get this stuff out of here. Back when I was in geometry class, and I was doing proofs, do you remember things like side, side, side? Angle, side, angle, 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 side. Remember all that stuff from geometry?
Yes.
Well, there was one combination of letters. We got side, angle, side, we got all that. There was one combination of letters that was off limits. Because it makes a bad word. You can't use angle, side, side. Okay? Can't do it. Look at what I got here, guys. I have angle, and then I have side, side. The reason you couldn't use it in geometry class was because it's called the ambiguous case. When you have angle, side, side, 3 things can happen. You can have no triangles, you can have 1 triangle, you can have 2 triangles. So you can't use it for a congruence theorem. Yesterday, guys, we had angle, angle, side. You had something like that? Angle, angle, side is a congruence theorem. So when you have angle, angle, side, there's only one thing that's going to happen, and that's you're going to solve the triangle and get the rest of your stuff. It's only angle, side, side that causes us issues. Now, you're lucky. I'm never going to try to trick you. The question is going to say, how many triangles are possible? So you're going to know, oh, I got angle, side, side. I'm going to set up my law signs, and I'm going to see. Okay? All right, let's see what's number 3. Let's see what happens with number 3. Go ahead and draw your picture. You'll draw the same, I don't care what picture you draw, but I'm going to draw the same picture I've been drawing. You label everything in the same spot. And I'm going to set up my law of signs. So angle A is 85, side A is 15, and side B is 25. So what is my law of signs going to say? Sine 85 over 15 equals sine B over 25. So I'll cross multiply. 15 sine B equals 25 sine 85. And what do I divide by? 15. And then, since it's sine B, to type it in, I'll need to do second sine, inverse sine. That. I have a feeling I know what's going to happen. Looking at those numbers. Type it in, tell me what you got. Error. I think. I didn't type it in. Did anybody else get error? It looks like error. Okay, so what is the answer to the question? Zero. Remember, what was the question? How many triangles are possible? When your calculator spits out an error, there are no triangles possible. No angle B's. Alright, come on guys. Stay with me. It's not even a Friday afternoon. Come on. 60, this is 9. This is 10. Here we go. Oh, wait a minute. Sorry, this is E. We're doing E first. I got ahead of myself. We're doing E first. Alright, so set it up for me. Charlie, what's the setup? Sine. Charles, sine 60 over 9. Turn around, Cal. Sine 60 over 9. What's that going to equal, Charlie? Sine B, I meant the other Charlie, but thank you. Sine B over 10. Yeah, Charlie, you're not going to stand a chance. You need to know the law of sines, okay? So sine 60 over 9 equals sine B over 10. All right, now what do? Cross multiply. So 9 sine B equals 10 sine 60. And we divide by 9 because this is a unit. So we're just going to divide by 9. And then we're going to type into our calculator second sine 10 sine 60 over 9. So when you get sine B equals second sine that thing. So I think we're going to, now I got hiccups. I think we're going to get an answer. Second sine 10 sine 60 divided by 9. I got 74.21. Anybody else get that? So then we immediately step over to the side, redraw the original triangle, and ask ourselves, could there be another B? Well, I don't know, but if there is another B, it's 180 minus the first one. So let's see. What would that be? 105.79. How do we know if that is an acceptable number or not? Look at the triangle. What is 60 and 105? 165. Is that good? Yeah, the only thing that's bad is if it makes more than 180. That doesn't. So how many triangles are possible? 2. The original 74 and the 105 are both okay. If this angle had been 80, then that one would not be okay. Do you see that? That would not work. But it was a 60, so it's all good. All right, let's see if you can try D. Try letter D. Get as far as you can. How many triangles are possible? Your answer is going to be 0, 1, or 2. And by the way, on test day, no credit for guessing. You have to show work. Because we know it's 0, 1, or 2. We're doing problem D. What?
When showing work, do we have to draw the picture out, or can we just automatically go to
You can set it up. Okay, let's go. Charlie Golden, you got it figured out?
I think so.
No, you don't.
I know.
Write something down, Charlie. You're smart. Write it down. You guys already have it done? What do you think? How many are possible?
Which one?
D.
one triangle?
Oh, one.
They say D. One for D. Julia, you're sitting there. What do you think? One. Everybody thinks one. Let's check it out. Sine 42 over 22 equals sine B over 12. So 22 sine B equals 12 sine 42. What am I going to divide by? 22. I can get this by itself. So then what am I going to type in? Second sine. Uh, 12 sine 42 over 22. Now, when I type that in, and I want everybody to do it, because sometimes we don't put parentheses where we need them and things get all boogered up. 12 sine 42, close the parentheses after the angle, always, you're gonna close that. Divided by 22. I got 21.41. Anybody else? Okay, now the minute you get an answer, remember your choices, 0, 1, or 2? Well, it's not 0 because you got an answer. All right? You got an answer. So now I gotta see, is there another answer? So I'm gonna go ahead, this one's 42. What would that second answer be? 158.59. How do I get that second answer? 180 minus the first one. Check it out. Can you have a 42 and a 158? No, you cannot. So therefore, one triangle is possible, and that's the one with the 21. Starting to see how this works? And that's all you have to do. All right, so one more. One more. Let's give it a shot. Yeah. Is this another 0?
Yeah.
I mean, that makes it easy for us. Yeah, it's another error. So I don't need this one. I don't need that one. Neither one of them work, right? So how many triangles possible? 0. All right, that homework's due Friday. 5-5 homework due Friday. Right now, go ahead and get out your 5-1 homework. And was there one in the 5-1 homework
We skipped
that you
2, 3, and 4.
weren't sure about? remember, I'm gonna mark it wrong if it's wrong, but if you gave it your best effort, it's okay. I want you to practice and I want you to learn, but I know some of these are gonna be a little crazy. Number 6. Now, I'm old, do a lot of these, so it's easy for me. I look at problem number 6, and the very first thing I notice when I just look at it is that in the numerator is a sine squared and a cosine squared. Anytime, boys and girls, anytime that you see a sine squared plus a cosine squared, you are going to make that a 1. Okay? That's one of the things, it should be automatic for you. Sine squared plus cosine squared is 1. So I have 1 plus tangent squared over secant. That looks like a quiz question. What's 1 plus tangent squared? Secant squared. And again, there's no magic there. It's on your paper. 1 plus tangent squared is secant squared. So I have secant squared over secant. What happens? They cancel. This time the extra secant is on the top. So my answer is just secant. All right, another one. From the homework. Any others? Which one? 5 is just one of those where we're going to rewrite everything because there's no add or subtract. So we're just going to rewrite everything. So, all right, so I have 2 over 1. Can't do much with that. What is tangent? Sine over cosine. Yeah, maybe you should write this down since you have a problem getting your homework done. Sine over cosine. How about cosecant? And you're not a whole lot better. But just pay attention. What's cosecant? 1 over sine. Or what do I do with cosine squared? What do I do with cosine squared?
Cosine squared.
Put it over 1. Cotangent. Cosine over sine. And sine over 1. Alright, so there's a lot there. But I can cancel anything that's in, everything's multiplied. So I can cancel anything on the top with anything on the bottom. I mean the matches. So it looks like I have a sine and a sine. Looks like I have another sine and sine. I got a cosine and a cosine. You see that? So what's left? 2 cosine squared. Three, same kind of problem. Here we go. This is like negative. I have to keep it. There's nothing to do with it. What's tangent? Sine over cosine. What's cosine? Cosine over 1. Cosecant, 1 over sine. Sine squared. Sine squared. Who sets an alarm for 3:09?
It's not
That's
alarm,
a
it's
fine line.
fine.
Somebody left their phone.
And cotangent is cosine over. Okay. do we make it stop?
Find it.
All right, so what do we got here? Let's see what cancels. Cosine, sine. Now, be careful here. I can cancel 1. And what's left? Negative sine, cosine? All right, what haven't I done? I feel like I've done most of them. Number 1. Okay, number 1. What's in the numerator? Nas? Nas? Can you find that phone and turn it off? No? Can you find it? And turn it off. So what have I got? 1 over cosecant? Do I ever leave 1 over? I never leave 1 over. So what is 1 over cosecant? This is problem number 1, sine. So the answer to problem number 1 is sine. All right, let's look quickly at number 2. If we get through all these, you don't have to turn it in. So number 2 says tangent divided by secant. That's what number 2 says. Tangent divided by secant. What is tangent? Sine over cosine. Divided by what is secant? 1 over cosine. Now this is not a times, this is a divide. So what do I do in a divide problem? E, change, flip. And what happens? The answer is just sine. All right, there should be 1 left. Which one is it? 4. Okay, number 4. What is in the numerator? Sine squared. 1 minus cosine squared is sine squared. The denominator is sine. We're going to cancel. And this one is also sine. A bunch of them are sine. That one is also sine. All right, so if you are here today, don't turn your paper in and I'm just going to give you automatic credit because I know you got it right. So. Except now you can write it down, so I can't really give you credit. Now sit down, honey. We gotta have prayer. So you got homework due on Friday, and that's all.